Okay, I just wanted to make a quick video to help you guys out with 2.1, and hopefully you kind of maybe remember the distance formula. And this one's kind of common sense, actually. Like if you have a point, you know, obviously, well, let's do this, like 0, 0, and what, 3, 0? You know, it's horizontal, so you're like, ooh, 1, 2, 3, a distance of 3 apart. Or if I put another point up here, maybe, you know, 3, 2, and you're like up here, and you're like, oh, there's a distance of 2 vertical, because it's up and down. But what if it's a slant? You know, like what if it's this distance, the distance between this point 0, 0 right here, and this distance that's at a slant? Then you can't count, right? Like I can't just be like 1, 2, you know what I mean? Because if it's on a slant, it's going to be a radical usually. I mean, sometimes it can be a perfect square, but not very often. So how do I do that? Well, if you look at this, as soon as anytime in math you see a right triangle, you're like, ooh, Pythagorean theorem, right? Like a squared plus b squared equals c squared. And so if you don't want to know the distance formula, if you know this, you can always figure it out. So the distance here is 3. The distance here is 2, do Pythagorean theorem, so a squared plus b squared, 13, so whatever the square root of 13 is, that's going to be this distance right here. And so someone is like, okay, well, you know, how did we just do what we did? Well, do you see how we subtracted our x's to get the 3? That's that guy, and then we squared it. So really what we did is we subtracted our x's to get how far apart they were, 3 to 0. And we squared it. And then how did we get the difference on the y side? Well, we took the 2 minus the 0. Well, that's just subtracting your y's. And we squared it because it's Pythagorean theorem. And then what was the last step we did down here? So we squared, and then we square root. And so right there you have the distance formula. Okay. So, and it doesn't have to be in that order. You know, if you like to put your y's first or whatever, that doesn't matter. So x2 minus x1 squared plus y2 minus y1 squared. Sometimes you see absolute values on these, but you don't need them because if you square a negative, it becomes positive anyway. Sometimes people just write it like this, like change in x squared plus change in y squared. Because it's really just Pythagorean theorem. It's a squared plus b squared, and then the last step of Pythagorean theorem is to just square root. So, you know, if I just have 2 points like -2, oh, I don't know, -5 and -5, 8 or something like that, and I want to know the distance between these 2 points, I could graph it and do Pythagorean theorem, or I could do the formula and I could say, okay, and again, it doesn't matter if you do x or y's, you can do either order. Sorry. So I'm going to do x, -5 minus a -2 squared plus 8 minus a -5 squared. And let's see, what is that? See how that becomes negative? But that, sorry, it doesn't matter. And that's what, 13 squared. And so I come over here, and a negative times a negative is a positive, and that's 169. Oh, can I add today? Maybe is that the square root of 178? Whatever that is. Okay, and we could simplify that or get a decimal. If you don't like this formula very well, another way to get change in x and change in y is to kind of do how I actually like to get slope. So make like an input-output chart. And what are my 2 points? I think those are the 2 I chose. And just do change in y, like kind of how did this go up? Think of temperature, it went up by 5 and then 8, so that's what, 13, up by 13. And this guy went down by 3, that's your change in x. And so then when you do your formula, you have 13 squared for the y squared and what, -3 squared. And again, commutative, doesn't matter how you do those. Square root of 169 plus 9 is the square root of 178. And I don't know if you guys remember, but if my math lab asked you to simplify a radical, so like say you do this whole Pythagorean theorem-y guy and you get the square root of 40, remember to rationalize, you pull out the biggest square root. 4 is the biggest square root that goes in there. 10 doesn't have a number that has a square root in it. And then you write 2 radical 10, that's called rationalizing, okay, if you remember that. So if you have something like, say, 200, you'd be like, okay, usually you divide by like 2, 3, 5, kind of like prime numbers here. So if I look at this, I'm kind of like, well, if I take the 2 out, let's see, the square root of 2 and the square root of 100, the 100 part has a square root, and that's the biggest number. So you don't want to just do like 4 here, 4 and 50, because 50 still has a square root, right? This could be square root of 25 and what, square root of 2. So you want to make sure you pick the biggest. So then you'd square root the 100 and get 10 radical 2. Okay, so that's the distance formula. And again, you can always graph it and, you know what I mean? Like draw the triangle and look at it. So if you're at like -2, -5, put a dot there, and then what, -5, 8, I didn't draw that very well, did I? 3, 4, 5, and then 8's up here. I mean, you could draw the right triangle, you know, and kind of look at it that way, but that gets to be kind of a pain sometimes. All right, the other formula in here is the midpoint formula. And the midpoint is like the balancing point. So if you think of average, that's kind of like an average. Because like if you have 8 and say 2, I know a lot of you are like, ooh, you add and divide by 2, that's how you find average. Well, it's the formula for average. But what does average mean? Average means kind of like, you know, you meet in the middle. So if this is like a dot plot, 2, 3, 4, 5, 6, 7, 8, and I have, say, how many pets do you have? One person has 2 pets, the other person has 8. The average is like when you bring these in like a fulcrum on a teeter-totter. So like if this dot goes in, this dot goes in. If this dot goes in, this dot goes in. And if this dot goes in, this dot goes in. And notice the average is 5 because that's the balancing point. So the word, you know, averaging is like the midpoint. It's the average. It's where they're at, okay? So if we have 2 points, it kind of makes sense, like it's just, again, don't make math hard. It's common sense that if I have something like this, it's like, oh, so, you know, if I graph what, 4, -8 somewhere down here and 10, 4, maybe up here somewhere, right? The midpoint is like this point right here. Well, that's kind of that balancing point. It's like if this goes in and that goes in and that goes in. So it makes sense that you could just average your x's and average your y's, because that's what average means. It means the middle. Like if you just have 2 numbers, it's the middle. So it makes sense with 2 points on a line, the midpoint or the middle is going to be the average. So I'm going to take 10 plus that. So what's that? 14 divided by 2. And -8 plus 4 is what? -4 divided by 2. So what is that? 7 and a -2. Okay, and that should be the midpoint. So again, hopefully both of these things kind of make sense. If I give you one side, let me see how much time I have. So say I give you the midpoint is 4, 8, and I give you one end point is maybe, I don't know, 2, -3, and I want to know the other end. So, you know, we're trying to figure out this guy. So let's kind of think about what we know. Like, you know, if this is what, 2 -3s down here, and 4 8s here, that's the midpoint, right? So you could graph it, and you could be like, oh, I'm going to go up and over to get to the midpoint. You could go up and over to get to that other endpoint, okay? That would work. The other thing I could do is algebra. So I could say, oh, I'm going to average these, right? So if I take the 2 and the x and divide by 2, that would average that. And if I take the -3y and the 2, that's going to average that. And so how does that help me? Well, because I know the answers to these. I know the answer to this guy is 4. So I'm going to set my equation. And let's see what I get. Double and double. So 2 plus x equals 8. Okay, so I just double both sides. And so what do? Subtract 2, subtract 2. I think I get 6 for that. All right, and then this one, I know the output, the y values have a midpoint of that. So divide by 2 is 8. Double both sides to get rid of that fraction. -3 plus y equals 16. Add 3, y equals 9. So it looks like 6, 9 is that other endpoint. All right, now does that make sense? Where were we at? This one was at, I don't know, I just kind of graphed here. Let me try to actually kind of make it to scale a little bit. So if I have 2 -3, okay, so here's 2 -3, oh, positive 2, -3. All right, and then the other one was 4, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 4, 8, okay. And this one was what? That's the midpoint at 4, 8. Okay, so let's see. So let's kind of think about what I did. I went up how much to get all the way up here? From -3 to 8, I went up 11. And then to get over here, I went from 2 to 4. So that's a distance of 2. So if this is the middle, right, then I know that this line is going to keep going at that same slope, right? So I got to go up 11 and over 2 again. So I need to go all the way up 11 again. Then I'm going to go over 2. All right, so if I go up 11, that's going to impact what? That's going to impact my x, or my y, sorry. So that's going to be 19. I see where I caught an error. And then I'm going to go over 2, and that's 6. And so if you go back, I don't know if you guys caught it. Julie, hello. 16 plus 3 is 19. I don't know if I said 9 earlier. I think I probably did. This should be 19 if you can add, or if I can add correctly. Okay, but I kind of caught it because when I check my answer, I'm kind of like, okay, so I'd have to go up 11, 2 and up 11, 2. And then it's like, oh, it has to be way up there. What did I do wrong? And I caught my error. Okay. But if you want to solve it with algebra, you can. Just be careful. All right. And kind of think about your answer, whether it makes sense or not. I'm trying to think if there's anything else. I guess we could do a distance formula real quick before I go. So say I give you, I don't know, 4, -9, and 7, -7, 2. Again, if you forget the formula, just do Pythagorean Theorem. So just kind of sketch it and be like, okay, -7, 2, and what, 4, -9, and kind of, you know, sketch in a triangle here. And it's going to be the right triangle. And then you're kind of like, okay, I want this distance. And let's see, which one is this? This is -7, 2, and this is what? +4, -9. It's right there. Okay. And so then you can kind of look at like, ooh, how far apart is this on the x? It looks like -7. So 7, 8, 9, 10, what, 11 going this direction? And then you're like, ooh, how much on the y? -9, 2, that looks like 11 again. And you could do Pythagorean Theorem with those. But let's do the formula. If you want to, you can do, you know, -7 minus 4 squared because of Pythagorean Theorem. 2 minus -9 squared because of Pythagorean Theorem. And again, it doesn't matter if these are negatives. When you square a negative, you still get a positive. So the order, you know, isn't going to matter here. Just make sure you don't get negatives. 121 plus 121. If you like to do it this way, 4, -9, -7, what was that? 2, is that what I picked? Just do change in y. So let's see, that guy went up 9, 10, 11 there. And this guy went, what, down 11? Okay, change in x. And so then you can just do Pythagorean Theorem with that. So 11 squared, and again, -11 squared. Do not get any negatives, because in Pythagorean Theorem, that would be impossible. So what is that? 242. And again, if you want to simplify that, you know, break it in like a 2, a 3, a 5, something. And obviously, I know it's 121 because we just added it twice. So that'd be 11. Square root of this comes out of jail, and this guy's stuck in jail. Hopefully that helps. If you have questions, let me know. This is section 2.1. And again, keep plugging away on chapter 1. I know you hate it, but we need to get through it. So hope this helps. Take care. Bye-bye.